So in this spirit, I do invite now the industry side, Mrs. Papazoglou, who is a project engineer at Morand Rai Management from the Agalikoussis Group, is going to talk to us about research challenges in shipping.
Good morning, ladies and gentlemen, esteemed speakers and guests. It is really an honor for me being here and being able to share the challenges that we face from owner's perspective when we are trying to bring our green retrofit or new building projects where we incorporate equipment or systems in the vessels that yet they have not been commercialized into reality. First of all, I will speak about the technical challenges. We all know that when we are in a research phase or in a concept phase, we are in a control environment in the laboratory. And in the theoretical studies, when you come up with nice numbers, they are based on assumptions. But in reality, on the vessel, the environment is really challenging. It is unpredictable. And the first and most important challenge we're facing is the technical challenges. And it has to do with the integration of the equipment and systems on board. And for instance, when you're actually bringing an equipment you have a prototype on the laboratory, you're trying to bring it on board, then you need to integrate it with the existing systems. You have to face also stability challenges, strength challenges, because you not only have the equipment, but you have also the auxiliaries. You may need also some big storage tanks. And of course, you have also to take into account the efficiency. You bring an equipment that you believe that it will make your vessel more efficient, but in reality, it consumes more power. So these are the technical challenges, and I will move on the operational challenges and the health and safety challenges. As I said, there are systems that have not yet been commercialized, so there is not real market feedback on the safety issues, hazards, and also on the operational challenges. So the training that you need to do on the crew and the human factor, unfortunately, is the most unpredictable. So the training is not as sufficient as there is not any feedback and lessons to be learned from the industry. So you need to do a really thorough risk assessment. You need to do HAZID and HAZOP, hazard identification, operational hazards identification, before you start the basic engineering. And of course, you need to take into account some, not only the equipment itself that may be complex to operate, but also hazards, toxic hazards that will be used by this equipment. And what comes to my mind is ammonia. Ammonia as fuel, which is a big trend now. We also look into that for a new project, for a new building project. But even though the biggest technical challenge, the combustibility, has been resolved in the laboratory by man, but in reality, we have not resolved yet the toxicity. That, of course, it has to do with the safety of the crew. A little bit of ammonia is lethal, actually, for the crew, and that the fact that it's very, very corrosive for the equipment and the systems. And I will move on, the last but not least, the financial challenges, OPEX and CAPEX. You make an investment, you want to see, from owner's perspective, a fast return on investment. And on the other side, you have also the operational costs, which you try to keep it minimal. You want to keep it minimal, but if the equipment is too complex, the OPEX can be very high, so you don't really see the benefits. And if you have many years like return on investment, this is something that many times it's a no-go. How do we resolve all these challenges from owner perspective? What we do, we enter in joint development projects where we participate, classification societies participate, shipyards, research centers, the makers, and we get together, we sit down together, we exchange information, we work closely. And of course, especially the classification societies and makers, they share also feedback from other clients who are also trying to bring these projects into the market. And many great minds get together and we find a solution. I believe that with cooperation and working closely is the only way that we can overcome these challenges and really not only bring all solutions to the market, but also contribute further and help also others to bring this to the market. Thank you so much.
Thank you so much for this most structured and very well organized presentation of the key challenges. This is why I like the engineering approach always, although I'm an economist. So our next speaker is again from industry. Thank you very much, Mr. Christodouloulos, for coming from MAN as a managing director. As you know, I do have a historic relation with your predecessor, so please.
First of all, I would like to thank you for the honor that the university and the organizer of the event made to MAN to invite us for being in the first HEOS Shipping Summit. For us, it is very important to have always a dialogue with the ecosystem that we are acting. And I will show you also to my presentation where I will try to accelerate it as much as possible or extend it, we will see. What we are doing, first of all, MAN is well known about the two-stroke engines for the shipping industry. However, this is not only MAN, it is this is not the only thing that MAN is doing. We are part of the future making. This is our motto for the technology that we are building up. Part of a bigger family. Most probably, the most of you don't know that we are belonging to the Volkswagen Group, and we are the only non-automotive company of Volkswagen Group. And one of the reasons that we are belonging and we will be belonging with the Volkswagen Group is the golden mind that the board of VW believes that we have really to contribute significantly to the decarbonization. So we have and we are building up technology for decarbonization, for digitalization. These two things are going together. And of course, we have also our, as a main pillar, to move big things to zero, which it means to contribute to the decarbonization till 2050 to be close to zero. We try for that in many markets, in shipping markets, in the energy sector, in the heavy industries, the heating, in refineries. And as far as you can see in the next slide, we have a variety of products, not only the well-known two-stroke and four-stroke engines that they are applicable for the shipping sector, but also have carbon capture that we are developing even in Greece with an engineering and R&D department. We are working a lot in the hydrogen for production of hydrogen, but also for usage of hydrogens. We are doing on a industrial scale heat pumps for district heating, for big industrial companies, canning companies, or companies that they need temperatures. And of course, for our sector, we are working on the retrofit of existing equipment, but also we are developing new green engines. We have a very ambitious target until 2030 to contribute up to the 10% reduction of the CO2. This is our ambition, and we try for that. With a study that took place almost 3 years, we identified that in specific sectors we can contribute with the numbers that they are given in this table: 2% in the shipping, 5% for the carbon capture, 2% for the heat pumps, and 1% for hydrogen. More specifically, again, for shipping, you know how much the percentages are. We have, of course, a significant role in these numbers because we have a dominant position in the shipping market. Close to 80% of the two-stroke main engines are designed or produced now from MAN Energy Solutions. And let's talk more specifically how we develop these technologies and how we communicate with the market. The traditional way is to generate the idea and to follow this path, which it means that we generate the ideas, we refine the ideas, we assess, we make a pilot projects up to a certain extent, and then we start the heavy stuff, which is the development and at the end, the scaling up of our technology. This is the traditional way for doing R&D. However, we have seen the last many years and the last decades that the research is not only a process that has to be inside, it is a process that it is affected from many factors, like, for example, of course, there is a strategy and the planning and the business planning of the company, but we have to deal with the society needs, with the environment, with the new data status that we are facing, with the brand image of our company, the perception that the end users and the society has for our company. So taking all this in account, we have a specific project management methodology for research and development project. And it is governed from the principle of gates. So we validate a business need, or first of all, we are a company, and so we have to take care about the business environment, the business objectives that we have. We create the idea, we plan, we execute, and we hand over at the end of the stage of the final product stabilization, our technology. For the idea, we support overall the business and the technical goals of the market, of the strategy that we have. We use realistic technical solutions. We try to use realistic technical solutions. We also identify the potentials that we have in the market in order to have a realistic and ambitious materialization and usage of our technology. We deliver the project as have been planned and agreed, and at the end, the market potential has been reassessed, and we try to optimize to make the final tuning of our products. This is the process that we are following for the research and development strategy. Now, there are 4 key questions. Why we should do the project? The answer, as it is mentioned also in my slides, is called the project business case. What does the project deliver? The answer to this question is called the project solutions that we are offering, that it consists of the deliverables that we want, how we will carry out the project, and this is the project approach, and the risk. The risk is the uncertain event that will happen during this process. Other factors that contribute to the decision process of a research and development has to do with the idea, the regulatory framework, the customer request, the sub-supplier support, and the service experience. And all of them, they contribute in order during an R&D project to adjust it accordingly. We have the design side, which is design, verify, receive some challenges out of this verification, analyze the root cause of the problems that definitely will pop up, and at the end, proceed to corrective actions in order to deliver a ready-for-use product. And to deliver a ready-for-use product, we call it the product stabilizations, where they are passing from these 6 stages. We observe that there are failures that happen. We report and we try to collect as much as document as more elements for this failure. We evaluate the potential solutions. We define the immediate measures, and also we inform the customer to cooperate together to develop potential solutions. We develop and validate the solutions, and of course, at the end of this process, we roll out the adaptation that we have done to our products. More specific about the 2-stroke technology, that it is the dominant technology for the marine propulsion till today. Our strategy has, in the center of our strategy are the people, which is the most important asset, and also we try through the leadership to have a sustainable organization. We develop engines that have the fuel flexibility, the dual fuel engines, where there is a big discussion, which will be the second fuel that we do believe that there will not be one solution, it will be multiple solutions. We work, of course, for the climate protections, and we develop the technology for the zero carbon approach. And also the last many years, we are working in parallel with our digital projects, where they are helping us for the development phases, but also for the operation phases. The two-stroke R&D department has a significant role to our organization. They develop the engines, the exhaust gas systems, the supply systems, and the digital solutions for the usage of our engines. They cooperate with all the stakeholders, with university, with shipyards, with ship owners in order to ensure that we'll have the most significant solution, the most optimum solution. And of course, we are working in a constant basis in our in-house test centers and also in the licensing side, creating, I will not call only digital twins, someone from my colleagues here has mentioned digital twins, but also creating many times prototypes, twins, in order to verify in the real life that what will go to release in the market has passed all the gates. An example for the development of an engine is the dual fuel engines that, as far as you can see, started in 2011 and still on a development phase, and it will continue to be on development phase, but the fundamentals, they have been based from 2011. This is not only applicable for the two-stroke engine, this is applicable, this process, for the entire product portfolio, that some of them I mentioned before, and has to do with the offshore and onshore application. Thank you very much.
So our time is up, but the presentations are not finished yet. So I will ask the two last presenters, despite the popular, I know, request, it is down to you. If you want to eat at 3:30, be my guests. I'm not eating after 12 anyway. So we have now Dr. Daginis and then Professor Kotrikla, and the discussant is going to try and save some time from the questions by wrapping up. And then if we have the patience, we can stay here for 5 minutes more to go through the Q&A. Sorry for that, but it was a popular request that I do allow time to the speakers.
Thank you very much. Pampouliou, thank you to our participant. The challenge in maritime industry is to reduce the environmental footprint. So thanks to Mrs. Papazoglou and Mr. Christodouloulos that is make their very interesting presentation, we saw some images of the technologies that they present. Actually, the area of exploitation and development is innovation, technological systems installed in the ships, and for propulsion related to zero emission carbons. The emission of this fuel either is reduce the CO2, carbon dioxide, or is a bit of, can be part of the natural carbon cycle. All the green fuels have limitations, as says previous Mrs. Papazoglou, and the innovation, it comes from the manufacturers, the bigger manufacturers in maritime industry, to face problems that is the carbon dioxide that emitted each year from maritime sector, that it's about 940 million tons. The goods traded around the world by the ships are transported via the maritime shipping is 19%, and 70% is the carbon dioxide emitted by the reduction from carbon dioxide by 2040 and to 100% down 2050. MARPOL annexes about emissions of NOxes are we have a limitation that's already said previous, and we have alternative fuel that can be used on the ships engines, ammonia compliant with regulation, methanol, liquid petroleum gas, liquid natural gas, ethanol, and MGO, marine gas oil. This is the agent that says before Mrs. Christodouloulos, Man and Burmeister, how can achieve this aim is the excuse me. It's the opportunity to use LNG on two-stroke engines. That's the previous one. That's the previous one engine, and gas engines, then ethane, methanol, LPG, and now ammonia and hydrogen. Also, Wärtsilä is another manufacturers in engines in the sea for ships. What exactly happened? That is the LNG fueled ships that use LNG system operating with to the engines there. LNG from the tank goes through gas valve unit in the engine, and then now due to the combustion and operation with LNG, that engine, the two-stroke engines, can use the ammonia in shipping system. That's showing it is very safe because and face challenges about corrosives and the environmental issues. What is happening? How it is inside this one. This one is a cylinder of those engines that previously see, and the ejection of that alternative fuel is coming through technology of this ejector. The yellow system is the alternative fuel that's supplying to the engines, and finally, the implementation of the technology in maritime industry can face many challenges. And this is the cost, the compatibility with existing technologies, the data of security, the employing and training and education, and that's we face in the future for minimize the carbon dioxide in the atmosphere, in the environment. Thank you very much for your brief.
After wrapping up the current trends, it is time for the last presentation before our discussant intervenes, which is one of our latest projects, which is very focused on atmospheric pollution.
Thank you very much, Ms. Ufanopoulou. I'm very glad being with you today. So, I'm going to talk to you about the quality of the air we breathe. The quality of the air we breathe is influenced by several chemical species. The most important and most dangerous are the so-called particulate matter. They are mixtures of liquids and solids floating in the air. And they float because they're very, very small, tiny, 2.5 micrometers and less. Okay, 2.5 micrometers and less. Take this. Okay, so due to their importance of these particulate matters that are in the air, we are breathing them and affect our lungs, but also cause strokes, etc. The European Union now is in a process of updating the rules regarding the thresholds. They will set lower thresholds, more strict thresholds, but also regarding the monitoring of these pollutants. It's very important. The first step what we need to do is, okay, no? The first step we have to do is to know the concentrations of the pollutants in order after that to be able to take measures, informed decisions. And finally, the actions about the activation of the okay, yes, the activation of people. So what we have done in a project is that we employed a network of low-cost sensors. What are the low-cost sensors? Traditionally, the monitoring of air quality happens by sophisticated, complex, and very, very expensive instruments that are run by state agencies or universities. The last years, due to innovations in different aspects, we have an exponential growth in the employment, in the development and employment of low-cost sensors for the monitoring of air pollution. These low-cost sensors have many advantages. They're portable, they're cheap, etc. But they have also, of course, a very important drawback, which is that they don't have the accuracy that they have the sophisticated instruments. I want to say that the difference in cost is in the order of 10 or 30. Like, for example, a low-cost sensor costs 500 euros, and an instrument like we use traditionally it costs 15,000. No, why it doesn't work? Doesn't? Did you? Okay. Yes. So the previous one, please. Thank you very much. So what we have done? Yes. The next one. Sorry. Okay. We have employed a network of 7 sensors in the Greek Aegean Islands at the framework of an Irish project coordinated by Professor Polidoropoulos and Hanopoulou. And we have monitored several parameters, including particulate matter with a diameter of 2.5 micrometers. Next, please. The previous one. Thank you. So the first step, what we have to do, and I have to focus on this when we use these cheap instruments, in order to have good data, is to evaluate their performance. If we evaluate their performance, we know how good are our data. So we did this, and as you can see in the graph, the performance of the sensors are quite good. What they do, they're well correlated with the reference instruments. What they do is that they overestimate the concentration. So we applied an equation in order to correct our data and improve the accuracy of the sensors. Next, please. Okay, yes. So what we have done is that we have done several campaigns using these sensors. One type of campaigns were in the port of Chios. What we have done, went there and before the arrival of the ship, of the big RoPax ships that come here, and stay there till the ship was departed and monitor the concentrations of particulate matter at the port. We have the emissions by the ship and also the emissions by the cars and trucks. And also, of course, we have the general background from other sources in the city and in the island. What we found out was that in general, the levels of pollution were not high, as you can see from the orange bars there. It was one case only that we have a really high level of pollution, which was due to stagnant conditions. When we have no air that blows, or we have air that blows from the south. There we had one before wind, that was coming from the south. So we have this high concentration. All the other cases were really low concentrations, and because we were connected with north winds, and higher wind speeds like 3, 4, etc. We're in the summer, as you can see. I have put there a line which corresponds to the European Union threshold limit and also to the World Health Organization's guidelines, which are year averages. Our data are 1 or 2 hour averages. I didn't put it in order to see exceedances of the thresholds. I put it just to have an idea of what are the limits. Next. Also, we have made some campaigns at the ferries garages, and of course there we found out what we do, that we had the sensor in a car. The car was approaching the port, and then the car went inside the garage of the ship, and of course there we found higher concentrations. For example, in the Piraeus port we have average concentration of 5 micrograms per cubic meter, whereas in the garage of the ship we have 51. The concentration of 51. This is of course expected because we have too many cars, too many trucks in a closed area. The good thing is that the exposure of people in these concentrations is happens for 15 minutes, something like this, which is not high, because the effects of a pollutant depend on the concentration first, but also on the time of exposure. Yes, could you please? Yes. And okay, the final thing I would like to show you is this, which is the general urban picture in Chios, because we have also established a sensor in near here in an area of representative pollution, and in all the islands, and we found out that the concentrations were high, especially in the winter, and especially during the late afternoon and evening hours, which make us feel confident to say that these high levels of pollution in winter are caused by the heating of the homes that use now biomass, like in fireplaces and stoves, etc. So we believe that the main source of pollution in the islands is this, the heating of the homes. There's heating. Going to the conclusions, thank you very much. So it's important to monitor the air quality because it is dangerous for public health. And all these climate mitigation measures that were talked about today help to this, because we use less fossil fuel burning, and we have the very welcome side effect of less toxic pollutants in the air. These sensors could be used in supplementing the official networks of sophisticated instruments. The very important thing you have to do is to check their quality, to know the quality of the data, because data of unknown quality are data that we cannot use them. And finally, this data can be used in raising awareness of the people and in also informing the decision-making process to take measures to combat the pollution. Thank you very much.
Following this, I'm adopting one of your sensors in my bedroom, which is not very far away, and I can correlate that with the smell when the ship's coming, or when the neighbors are starting their barbecues. Exactly. So it is time now to wrap up. Can we do something about cooperation between research and industry? Okay, great.
So dear all, thank you very much for the invitation and this excellent conference, and quite interesting. I would like to wrap up with just sharing some thoughts with you. The first thought is that we were talking about climate change. Nowadays we talk about climate crisis, but I think we're in a climate war. And it's a war because we have casualties. We saw in Thessaly some days ago that we lost human lives, a lot of them. We lost thousands of animal lives, and we have destroyed infrastructure, the railway networks, roads, factories, and even we lost 5% of our GDP, of our annual GDP, in one day. So I suppose this is a war, and we want to fight this war and be the winners as soon as possible because we don't have running out of time. And the key for winning this war is technology. As a matter of fact, we want from technology to save us from the problems that the technology that we're using now is producing. But we don't have another weapon, so technology is the answer, and especially in changing the climate back to normal and having all these impacts diminished. Especially in the shipping industry, we have the same problems to face. We must, in very quick time, especially after the new IMO guidelines about bringing back 10 years all the targets that IMO had put before, we must act very fast. We must be very concentrated in what we do. We must spend a lot of money in research, and we must be very innovative and maybe find all the new solutions that we have, because unfortunately, we don't have a good solution at the moment for decarbonizing the shipping industry. So technology is the key to win this war. And the answer is, and the question is, can Greece become a technology innovation hub in this war and then have gains as a country, as an industry? There are a lot of aspects that could help us to do so. We need technology, and from other points of view, especially if I put my hat of the Hellenic Short Sea Shipowners Association, we know that short sea has a very aged fleet and we need to renew it. But we need to renew it with new technology aspects, a new technology, applying new technology, because short sea has the problem that apart from IMO, it has also the European Union. It's subject to all the new restrictions and there is no time for that. So we need technology, and we need technology here in Greece. Yes, Greece could become easily a technology hub for shipping industry, for new technologies and for decarbonizing shipping. All the speakers here, fortunately, from everyone from his point of view, he declared that we do a lot of work here. And not only we have all the institutions, I mean, the laboratories and the universities, the research institutes that perform a lot of work on that, a lot of work, and we saw it and was amazed about what is the work done here. But also we are the dominance in the shipping industry. The Greek-owned fleet is the biggest in the world, and all the ship owners, we have realized that they spend a lot of money trying to comply with the new rules and try to decarbonize their vessels soon enough and be competitive in this global economy. So we have this, we have the people also, we have excellent minds. Unfortunately, many of our very good minds, students or professors, they are researchers, they are now operating and making the research outside Greece, which is not a very good thing for us, but we could, let's say, attract them back if there are the conditions to do that. So what's the problem with that? And this is I'll wear my other hat with the Hellenic Institute of Marine Technology, that we must make the conditions to be this hub. And to do that, we have the money, even from the European Union or from the industry. We have the researchers to do so. We have even technology providers like MAN, for example, that are very good in and very ahead in supplying applied technology at the moment, and being very, let's say, pioneering in that. But we must fight our battles ourselves in that. And what does it mean by that? Mainly, we must fight the state, that the Greek state should be the pioneer in focusing in research in shipping technology, in maritime technology. Because aiming on that, I think we could be helped and proceed in that. Without the help of the state, I think we have more bureaucracy, more barriers on that, less money, and let's say we spend time doing nothing. So I think we must press with all our powers in that direction to become an innovation technology hub and not only in alternative fuels that we can do it, but in information technology as well, in operation, because operation will play a significant role as well in this decarbonization and this proceeding. We have, of course, an external enemies. For example, China, I think, will be a main threat in quotation about being the first one in innovation technology, as it now concentrates all the technology. It has the yards, it has the money, it has the trade, it has the ports, and it has everything. And maybe in, I don't know, 5 years' time, it will be the pioneer and the excellent researcher and the excellent technology provider of the globe. And this is a race for time and money, but we must concentrate our focus. And I believe that having heard all our esteemed speakers before, that we have the power, we have all the conditions to become an excellent hub of technology, and this excel in another time and from another aspect to the shipping industry and the shipping business. Thank you very much.
I would suggest that if we want not to delay Simos Pallios from doing his speech on time, not going beyond what we call the academic, 15 minutes, το ακαδημικό τέταρτο, we should not take any questions. I'm sure there are, but we can put them together with any questions in the next panel. So to keep a bit the timetable as it should be. I think you do agree, isn't it? Yeah, yes. You do allow me, however, you have given me 12 speakers. You gave the others 5. If you think that women can do double the work, I do say yes, indeed, but double, not double plus 2, right? So next time you give me just double the speakers, not, and you just give me the same time. I think we're going to do that. So thank you very much for being patient with us.
I would like to turn it to Greek. Φυσικά και τώρα θα πάμε για ένα σύντομο διάλειμμα. Απλώς ήθελα να σας ενημερώσω ότι εντωμεταξύ έχουμε μαζί μας, τώρα με την κόρη μου, λοιπόν, ότι εντωμεταξύ έχουμε μαζί μας και 2 εμβληματικές φυσιογνωμίες της ναυτιλίας και της Χίου, η καθεμία από τη δική της οπτική γωνία. Ήρθε κοντά μας ο ομότιμος καθηγητής του Πανεπιστημίου Αιγαίου και ιδρυτής του Τμήματος Ναυτιλίας και Επιχειρηματικών Υπηρεσιών, ο κύριος Νίκος Λίπινας. Και εντωμεταξύ έχει φτάσει εδώ και κάποια ώρα ο κύριος Σιμεών Παλιός, ιδρυτής της Διάννα Shipping και μία από τις πιο εμβληματικές μορφές της ελληνικής ναυτιλίας. Ας απολαύσουμε το σύντομο